Hi, and welcome to another Level 3 Simultaneous Equations video. In this video, we're going to review the idea of writing equations. Now, in Level 1 and Level 2, you came across simultaneous equations which had two equations and two unknowns. We called them two-dimensional simultaneous equations. However, in Level 3, we're going to explore simultaneous equations that have three equations and three unknowns. We're moving into three-dimensional simultaneous equations. And a lot of these simultaneous equations are contextual. They'll have a story to it. So we're going to practice writing equations from stories. So let's get straight into example. Example 1. A number multiplied by 7 minus 9 equals 18. Well, we're going to start off by defining a variable x. That's going to represent the number. We don't have to use x, but in these equations we're using in Level 3, often it's easy to use x, y, and z. So x is going to represent our number. Our number's been multiplied by 7, so x times 7 minus 9 equals 18. So we're going to write it as x times 7 minus 9 equals 18. We know in algebra that we don't put x times 7, we always put the 7 first and we don't use a multiplication sign, so we're going to write it as 7x minus 9 equals 18. Right, let's move on to example 2. 2 times a number plus 3 times another number makes 39. So let's find our two numbers. X is going to represent our first number and y will represent our second number. So let's start off. 2 times a number, so 2 times our first number, x, plus 3 times another number, so our second number is y, so 3 times y, makes, when we say makes, we just mean equals or adds up to 39. So let's put it equal to 39. And again, remember in algebra, we don't use the multiplication sign, so we don't write it as 2 times x, we write it as 2x and 3y. So 2x plus 3y equals 39. All right, here's our third example. One evening, a pizza takeaway sold 60 pizzas. They sell small, medium, and large pizzas. Well, we're going to have to start off by defining variables. Once again, we have small, medium, and large pizzas. So let's define x, the number of small pizzas, y is going to be the number of medium pizzas, and z is going to be the number of large pizzas. So now I can write this equation. X plus y plus z, the number of small pizzas, plus the number of medium pizzas, plus the number of large pizzas, must equal 60, because we sold 60 pizzas that evening. All right, our last example for the video. Example 4. The mathematics department buys some Year 9 textbooks and some Year 10 textbooks. The Year 9 textbooks cost $40 each, and the Year 10 textbooks cost $55 each. Altogether, the department spent $1,625 on these textbooks. Once again, we need to make a definition first of our variables. So let's define the two variables. X is going to be the number of Year 9 textbooks that the department brought, and Y is going to be the number of Year 10 textbooks that was purchased. Right, let's start off. There are Year 9 textbooks and they cost $40 each. So we're going to write this statement. X is how many Year 9 textbooks we buy times $40. So it's how many textbooks times the $40. That'll give us the cost for Year 9. We know the Year 10 textbooks cost $55 each, so we're going to go y times 55. Y is how many Year 10 textbooks times 55. And because we spent $1,625 altogether, if I plus those two costs up, we're going to put that equal to $1,625. And again, we don't put x times 40. We always put the number first and no multiplication sign. So let's simplify it to 40x plus 55y equals 1,625. Thanks for watching.